Attention pour le décompte final. 3, 2, 1, allumage Vulcain.
Reaching for the sky. Space technology is a great fascination for people all over the world. Today, rockets transport satellites to their locations in space in a matter of hours. Engines generate millions of horsepower to break free of the Earth's gravity. Hundreds of thousands of people work in space programs around the world. Europe also has its own aerospace workhorse, the Ariane 5, Europe's most reliable rocket.
De la télémesure de la station Santa Maria, aux Açores.
French Guiana. The MN Colibri docks at the port of Kourou. The special transport ship comes from Europe and has components for an Ariane 5 on board. Her journey began in Bremen, Germany. From there, she sailed to Rotterdam in the Netherlands to load more components. And then to Le Havre in France, where she took the Ariane 5 main stage on board. Her next stop was the Italian port of Livorno, before heading across the Atlantic to Kourou in French Guiana. This is where the European Space Agency, ESA, has located its giant spaceport, from which all of the Ariane 5 rockets have started their journeys into space. The Ariane 5 is a joint European project and is regarded as the world's most reliable launcher system. There are currently two variants of the Ariane 5. The ECA version is the one that's used most, with a height of 59 meters, a diameter of 5.4 meters, and a liftoff mass of 770 tons. It's the European Space Program's workhorse. It can bring two satellites with a total mass of up to 10 tons to an altitude of 36,000 kilometers. The smaller ES variant is 53 meters in height. It can transport a payload of up to 20 tons to a height of 300 kilometers. And will be able to carry the four lighter Galileo satellites to an altitude of 23,000 kilometers. Ariane 5 consists of two stages, the main stage and the upper stage. The main stage, EPC, short for Étage Principal Cryogénique, is a giant fuel tank that supplies the Vulcain 2 engine. On the sides of the main stage, there are two solid propellant boosters providing the required liftoff thrust. This combination is the same for all Ariane 5 launchers. On top of the main stage is the upper stage. There are currently two different versions in the Ariane program, the short EPS variant and the longer ESCA version. The most important component of both upper stages is the control unit, VEB, short for Vehicle Equipment Bay. This is the rocket's electronic brain. Under the payload fairing, the difference between the two versions becomes clear. The EPS stage has a compact, reignitable Estes engine. On the payload adapter above it, numerous smaller satellites, or the large ATV space transporter can be mounted. The ESCA upper stage usually transports two satellites at once, using an HM-7B engine. The first satellite sits on the large tanks and the payload adapter. A transportation structure, the Silda, covers this and at the same time serves to accommodate the second large satellite. The payload fairing is variable in length and can be adapted to each specific mission. The individual Ariane components are manufactured in various places all over Europe. In Kourou, the rocket is then assembled for launch. Kourou is the second largest city in French Guiana, after Cayenne. At 83,000 square kilometers, the country is similar in size to Austria and lies only 500 kilometers north of the equator. Though not apparent at first sight, it is part of France and so belongs to the EU. Kourou, a former fishing village of 500 inhabitants, has maintained its charm despite the many changes. In the last 30 years, the town has seen considerable growth, with the population increasing fivefold to 25,000. That's because since 1979, this is the home of the launching site for the Ariane rockets, the ESA's spaceport. On the horizon, the MN Colibri appears after her successful journey across the Atlantic. Packed full of rocket technology, the ship prepares to make its difficult entrance into the estuary and down the Kourou River. The Colibri sails the last 5 kilometers to the quay down a specially dredged channel. In a complicated turning maneuver, the Colibri docks at the quay in reverse, stern first, guided by a pilot.
The port of Kourou is on a river with a depth of 3.8 meters. So not every ship can dock here.
Twice a month, the 2 ESA ships sail into the port. Besides components for Ariane 5, they also deliver parts for the smaller Vega launcher system, as well as for the Russian Soyuz rockets.
The only ship that docks here, between the Colibri and the Toucan, is a tanker, supplying the town of Kourou.
The sleepy port awakens. After the first containers with engine parts and smaller components, the 30-meter main stage is then also hauled out of the belly of the ship. 2 tractors, one at each end of the container, maneuver the largest section of the launcher system out of the hold. The upper stage from Bremen, Germany also leaves the Colibri and makes its way to Europe's spaceport, CSG, the Centre Spatial Guyanais. After a 45-minute drive, the convoy arrives at the high-security location. It covers an area of 750 square kilometers. There are 3 launch pads in operation here, for the Ariane 5 launcher, for the Vega, and a little removed from the others, for Russian Soyuz rockets commissioned for launch here by the ESA. The largest facility is the launch pad for Ariane 5, and is therefore designed for the largest payloads. Since 2011, the medium-class Russian Soyuz launcher also takes off from Kourou for the ESA, and has meanwhile taken a number of European Galileo navigation satellites into orbit. The 3rd launch pad is for the European Vega rocket, the little sister of the Ariane, which transports lighter payloads into space. For all launches, the spaceport offers favorable conditions because it lies on the equator. In Kourou, the aerospace scientists don't have to worry about the dangers of earthquakes. And there's no real threat of strong hurricanes either. So conditions are very good for operating a spaceport. The biggest advantage, however, is the geographical location of the spaceport. French Guiana is the EU region closest to the equator, and here the ESA can make use of the favorable slingshot effect for their launches. It works like this. The Earth revolves around an axis that runs through the North and South poles. For one revolution, the planet takes 24 hours. So if an object is on the equator, in one revolution it covers 40,000 kilometers in 24 hours. An object in Northern Europe, for example, would only cover 23,750 kilometers in the same 24 hours. This is because the circumference of the revolution is smaller. That means the object on the equator is already traveling at 1,660 kilometers per hour, and the object on the smaller northern European circle at only 990 kilometers per hour. So when Ariane starts from the equator, the rocket is 200 meters per second faster than if it started in northern Europe. This saves fuel and consequently weight, which can then be used for payload. The first serious building work for long-term space projects began in Kourou in 1965. Initially, this was to serve the French National Space Program and the first European projects. In the mid-1970s, the establishment of the ESA greatly enhanced the importance of the launch site in Kourou. From 1979, the beginning of the Ariane era, French Guiana became the major base for Europe's space program. Besides the various launch pads for the Ariane series, flight monitoring facilities, mission control centers, and integration buildings were also constructed in Kourou. Since then, the final assembly of the delivery systems and the payloads is carried out here. As time went on, more large complexes for production and flight control were added. They now give the spaceport its current characteristic appearance. Meanwhile, more building work has begun in Kourou. Progress does not stand still. This 750 square meter site provides enough space for the launch station of the new Ariane 6. And this is what it will look like. Ariane 6 will have the same scope of operation as all its predecessors, delivering commercial and scientific satellites into various orbits. It differs from previous versions in terms of its size. It will be a few meters longer than Ariane 5, as it will have a completely new upper stage. The variable use of 2 or 4 boosters is also something new. Ariane 6 will only cost half as much as an Ariane 5. One reason for this is that it will later be possible to assemble Ariane 6 in Kourou while it is lying horizontally. Its predecessor still has to be assembled while standing upright, which explains why the spaceport in Kourou is dominated by these giant assembly buildings. These two so-called integration buildings are only a few hundred meters apart. The BIL is one of the 2 biggest buildings on the entire site. It is located in the middle of the internal high security zone. This is where the rocket components are put together. The EPC main stage, which has been delivered from Europe, is erected one final time in the BIL. Over the coming 19 days, the Ariane 5 will be assembled here. The BIL is 58 meters high, and with its long hallways, it's the only building with sufficient space to move a rocket of this size. The Vulcain 2 engine is now fully connected. Without fuel, the main stage weighs just less than 15 tons. Slowly, it is lowered onto the launch pad and secured to it firmly. Fully assembled and filled with solid propellant, the boosters are now brought to the BIL integration building. These 30-meter boosters are highly explosive, which is why no one is allowed near the BIL apart from the transport personnel. On the launch pad, the boosters are mounted onto the sides of the main stage. Ariane 5's liftoff mass of 770 tons is the equivalent of 2 fully fueled and loaded jumbo jets. The boosters, each with their 241 tons of fuel, enable Ariane to lift off very quickly. Their thrust, enough to lift a mass of more than 1,200 tons, is the equivalent of approximately 45 million horsepower. Within 140 seconds, the launcher reaches a height of 65 kilometers and many times the speed of sound. The booster is a 30-meter-long pipe with a 3-meter diameter. It's filled with ammonium perchlorate and aluminum powder, with a rubber-like artificial resin as the binder. In the top of the booster, ignition takes place, and in 0.36 seconds, flames shoot through the entire booster. Burning from the center outward results in temperatures of 3,000 degrees and pressure of up to 65 bar.
Today we've filled the boosters with fuel, so that means we're standing here very close to a vast amount of pyro fuel. Each booster already has 287 tons on board. That's quite a lot of fuel. The main stage will only be fueled right at the last moment, a few hours before launch. This work has to be done very carefully. And the team has to respect all the safety protocols to make sure no accidents happen.
The cylindrical control unit is raised carefully upwards. Beneath its golden foil, this giant component houses the computers for the rocket's in-flight control system. The ring is now fixed securely onto the main stage. Integrating the compact Estes engine is the next task. For this Galileo mission, the cylindrical control unit has been given a heavier and stronger design, as it needs to hold this very special main stage engine in place. After 19 days, the main stage with its boosters, computer systems, and propulsion unit is fully assembled and securely fixed to the gigantic steel launch table. The launch table alone weighs 750 tons. On top of this comes the rocket at 500 tons. As there are only 2 of them in the Ariane program, the table is refurbished after each launch and used again. The launch table is a technically sophisticated supply system for the Ariane 5. From assembly to the launch itself, Ariane 5 remains attached to the table. Incorporated into this huge monstrosity is a power supply, thousands of media connections, countless pressure lines, and several cryogenic fueling systems. The giant steel structure stands on 32 railway axles that run on rail tracks. This means the launch table can be moved relatively easily, though very, very slowly. A special lubrication system reduces these strong frictional forces and makes it possible for a single truck to set the colossal steel giant in motion.
The truck is attached to this coupling. Now just imagine, the weight of the launch pad plus the rocket is hanging on here. 1,400 tons are being pulled along, dependent on this bolt. You've just got to have faith in it. That's what the truck's built for.
The truck that pulls the launch table out of the BIL has a 5,000 horsepower turbo engine and a 25-speed gearbox. That generates high torque at low speeds, thus making it possible to get the 1,400-ton load moving. This truck has been in operation at the launch site since the beginning of the Ariane program in 1995. Before the transfer of the start table and rocket, almost all staff must vacate the site. This also applies to Reinhard Hildebrandt. For him, it's just routine.
I started here in Guyana in 1984, so I've seen lots of rocket launches, over 220 in all. And I'm very proud of that too. I'm one of the few people to have been lucky enough. For me, the whole dream began with the moon landing. I'm from the generation that was able to watch it on a black and white TV. And from that, the idea just grew inside me that I wanted to work in this business. So for me, it's a bit like a dream come true.
While the staff are driving across the launch site in their cars, the Ariane 5 launch table is moving along a large network of rail tracks. The first route on the double-track rail system leads the table, complete with the Ariane 5, in a wide semicircle from the BIL building to the BAF building. Such transfers between the two integration buildings take place every 6 weeks. The giant gate is opened. The Ariane 5 first has to acclimatize, because out here it's more than 40 degrees. Now the truck positions itself in front of the launch table. Centimeter by centimeter, the truck pulls it slowly at a speed of only 1 kilometer per hour out of the building. For the rail transfer, the still open tip of the rocket has been covered with a hood. This protects the electronics from humidity, insects, and contamination. To prevent manipulation and sabotage, all openings on the rocket and the transport hood are sealed. Nothing must be allowed to go wrong that could interfere with the work in BAF, the second larger integration building. There, in the next few days, the satellites will be mounted onto the rocket. It then takes another 2 weeks to complete further checks and inspections. After 1.5 hours, the transfer is completed and the safety regulations are lifted. The staff are allowed back onto the site. The BAF building is a gigantic clean room and can only be entered through airlocks. Every operative wears special overalls, anti-static shoes, and always has a rescue mask at hand for their own personal safety.
We're very close to the fuel. It's stored here. And if there's an accident involving the fuel, we have gas masks, which give us time to clear out and get to the shelters. You have to wear something to prevent inhaling the poisonous gas.
The upper floors of the 90-meter building can only be reached comfortably by elevator. On the 9th floor, over 50 meters above ground, this is the workplace of the specialist team from Germany. The technicians from Bremen are in Kourou several times a year and are responsible for assembling the upper stage. Before the transport hood can be removed, the moisture level inside the rocket is measured. To do so, a maintenance panel is removed and a computer connected.
Today we've completed the transfer from the BIL to the BAF building. And the VEB, the brain of the rocket, has electrical equipment on board which is extremely expensive and has to be carefully monitored during the transfer. It shouldn't be too warm, and there shouldn't be too much moisture inside. That's relatively difficult here in Guyana. So we've installed a gauge inside, and we're just taking the readings now to check whether everything's gone well during the transfer.
The gauge readings are correct. The equipment has survived the transfer very well. The team can now begin their work. Otherwise, everything would have to spend a night under ventilation. Preparations are now made for removing the hood. Beneath it is the sensitive adapter that later forms the connection between launch vehicle and satellites. Every task on the upper stage is based on the 4-eye principle. A job carried out by one operative is monitored by at least one of his colleagues to prevent any errors. The responsible operations manager determines the pace and sequence of each task and documents every process.
Our operations manager is just filling out his job order. Here it's referred to as a FASO, and it clearly defines the scope of his work, which resources he's used, which employees he's worked with, And above all, which procedure was used. Each step and what was done is recorded here meticulously, and then it's stamped by the quality inspector. He's now signing off to certify that everything has been carried out properly.
Throughout the entire building, parallel to the work on the upper stage, the other parts of the launcher are being assembled. The regulations are very strict, which make the 14 working days a rather tight schedule to keep. Standing in the hall now is a fully equipped launcher, with boosters packed full of highly explosive solid fuel. Consequently, for safety reasons, no more than 60 people are allowed to be in the hall at any one time. There is a specific reason for this. In the event of an accident or an explosion, not all members of the specialist team would be killed, and so their entire expertise wouldn't be lost. Otherwise, there would no longer be an Ariane 5 program. Experience and knowledge are indispensable in the aerospace industry.
Alles klar?
Right? Are you ready? Nick, everything okay?
Okay. Bon. Montez très petit.
The transport hood can now be lifted off. Each specialist here on the 9th floor has already completed dozens of upper stages. Nevertheless, even for the old hands, there are always new challenges because this ES version of the Ariane 5 upper stage is rarely used.
It's the first time in 2 years that we've got our hands on this version. Over time, you lose a lot of know-how. People go into retirement. So every day, we have to try and carefully work our way and think our way into what we're doing.
This short ES upper stage will be used on the next flight transporting the Galileo satellites. The protruding truncated cone will later accommodate the payload dispenser onto which the 4 satellites will be fitted. The satellites are flown to French Guiana from Germany in a wide-body aircraft. Each satellite is transported separately in its own sealed container to protect it from damage and environmental influences. In an air-conditioned hall, specially built for payload integration, the technicians unload the devices, each worth 70 million euros. In the hall, the satellite dispenser stands ready. Mounting the 4 Galileo satellites in Kourou takes several days. Usually 1 satellite per day is attached to the dispenser. The entire procedure is carried out with the utmost care under clean room conditions. The folded solar panels and the insulation must not be damaged under any circumstances. Even the slightest damage to a single satellite would result in the launch having to be postponed. For this mission, the shorter EA variant of the Ariane 5 is being used. It is bringing 4 satellites into space simultaneously for the first time, and it requires the upper stage engine to have a very special capability: reignition. Currently, this can only be provided by 1 engine in the Ariane 5 program, the somewhat aging but reliable Estes engine. To release the satellites in the correct location, the engine is ignited several times. At an altitude of 160 kilometers, the Estes will fire up for 10 minutes and raise the upper stage to 1,200 kilometers. After coasting for 3 hours, another 7 minutes of propulsion will be applied to achieve a circular orbit at 22,925 kilometers in altitude. Here, the upper stage will realign itself. The 4 Galileo navigation satellites attached to the dispenser will be released in pairs at various points in the orbit. First of all, the satellites must activate their power supply by extending their solar panels. As the number of satellites increases, the network will become ever more tightly knit, improving the coverage of the Earth's surface. 27 satellites are going to cover the most important regions of the Earth, offering an alternative to the American GPS system. The fueled and completely assembled satellites are now ready to be transported to the BIL. The whole combination of dispenser and satellites is now pushed into an air-conditioned transport container. This Galileo dispenser is quite a rarity in the Ariane 5 program because the satellites are mounted to the sides and not, as is usual, on top of each other. The payload adapters are developed in Les Mureaux in France. The payload dispensers are also produced here. The major focus of production here, however, is the SILDA double launch system, which enables 2 satellites to be carried by the launcher at the same time. SILDA is used in the longer ECA version of the Ariane 5. The system involves 1 satellite inside the SILDA and another payload on the top of the device. SILDA weighs only 500 kilograms, but can carry payloads with a total mass of 10 tons. The engine ignites once for a period of 13 minutes, propelling the upper stage to an altitude of 700 kilometers under extreme acceleration. The first satellite is released at this point. SILDA then separates itself from the upper stage, freeing the way for the second satellite, which is released shortly afterwards. In the BAF final assembly building on the launch site in Kourou, the crew from Germany are just beginning their late shift. Preparations for mounting the 4 satellites onto the upper stage are in full swing. Specially manufactured stepping plates are laid on the upper stage. That's necessary before any work at all can be carried out on the so-called cone. They can't afford to cause even the slightest damage. Everyone is working with maximum concentration. All the team members for this assembly task have been specially flown in from Germany because that's where this component was manufactured. Consequently, they are the people who can provide the best expertise for the work on the upper stage. The final 2 stepping plates are positioned. To prevent impurities entering the upper stage, all gaps are sealed off with adhesive tape. The next important step is applying the MLI, the multi-layer insulation. This is an insulating foil made up of several layers, which serves to protect the tanks and electronics in the upper stage from the sun's radiation and from dangerous overheating during the unusually long 4-hour flight phase.
We're now in precisely the place where the satellites will be later. So that means every bit of dust that gets in here today will automatically be transferred onto the satellites, and that's something we want to avoid.
The gold and yellow insulation foil is applied in a predetermined order. Each segment is cut differently and fitted to the cone precisely to the millimeter. All sections of the foil are earthed and need to comply with a precise surface resistance value. For securing the foil, Velcro straps are used. They were originally developed for space travel because in the satellite zone, no materials can be used that might give off gas or get lost. This could lead to tiny particles being deposited on the solar panels, impairing their function. So felt tip pens, adhesives, or screws that could become loose during flight are all banned. Velcro straps, on the other hand, are the ideal solution. The German team takes photos of the assembly process, but not only as a memento for themselves. This special upper stage is used so rarely that team members reaching retirement age and leaving could easily lead to know-how being lost.
You lose so much over time, and then there are always new people coming in. People like myself and the old hands, we know that. So we want a kind of photo documentation of what we've done for those coming after us. It's just for us and for our team.
After 3 hours, the foil is in place and the job's done. A few kilometers away at the launch site in Kourou, technicians are making preparations for the transfer of the 4 Galileo satellites mounted on their dispenser. The air-conditioned transport container with the 4 satellites inside is moved to the BAF building by truck overnight. Stringent safety regulations are in operation because the satellites are filled with toxic fuel. On arriving, the satellites are launched on their first flight, but only up to 90 meters, hanging on the hook of a crane. Together with the dispenser, this payload only weighs 3 tons. For the Ariane 5, that's a lightweight. The challenge here lies in the number and the positioning of the satellites. The teams mount the dispenser on the upper stage. Both segments fit together perfectly. The payload and the giant rocket now form a stable unit. The fairing stands ready. For Ariane's Galileo mission, it has a height of around 11 meters. It's made from a carbon fiber reinforced composite material and insulated with cork and an anti-static paint. Manufactured in Switzerland, the fairing makes the Ariane aerodynamic and protects the satellites from frictional heat and the influences resulting from breaking the sound barrier. The fairing is high-tech. It contains radio technology for monitoring the satellites and provides insulation against sound and vibration. Slowly, the fairing is lowered over the 4 satellites. Any minor bumps now, and the project may be jeopardized right at the last minute. But everything goes smoothly. The shorter ES version has now attained its overall height of 53 meters and is ready for transport to launch pad ELA-3. "24 hours until liftoff. The Ariane 5 with the 4 Galileo satellites on board leaves the BAF final assembly building. Almost all preparations have now been completed. This is its final journey on solid ground. Thousands of people all over Europe have once again proved that together, great achievements are possible. Since the beginning of this Ariane 5 launcher, 18 months have passed, and each of its many thousands of components now has to function flawlessly. At 1 kilometer an hour, the special truck slowly draws the convoy the 3 kilometers from the BAF building to the ELA-3 launch pad. Since 1979, this is the 3rd launch complex to be added to the Ariane program. The ELA-3, short for Ensemble du Lancement Ariane, stands on a massive concrete base with a central supply tower. This is surrounded by 2 flame ducts, 4 lightning conductors, and various facilities for water cooling the table and launch pad. The water tower provides the necessary pressure and supplies the enormous quantities of water. The structure took 8 years to build, with the complex opening in 1996. "24 hours before the launch, fueling begins. First of all, the conical tank on the Vulcain 2 engine is filled with liquid helium. 6 hours before countdown, the process of filling the main stage with 25 tons of liquid oxygen also begins. This is followed by 145 tons of liquid hydrogen going into the upper tank segment. Both gases are super cold and have a strong tendency to evaporate. Fueling goes on until the moment the rocket lifts off. This guarantees the main stage will hold the maximum volume of fuel. A similar approach is taken with the cryogenic upper stage when this is in use. Up until liftoff, the launch table's umbilical arm maintains the tank pressure. As with the main stage tank, liquid hydrogen flows into a large segment, while liquid oxygen is filled into a smaller one. The solid fuel boosters have been completely ready for takeoff since they were mounted on the rocket in the BIL building weeks before the launch. Only the ignition has to be charged. Right next to the supply tower is the cooling system, which is fed from the water tower.
In the background, we can see the water tower, which holds 1,500 cubic meters of water that's used for cooling purposes. But it also mutes the sound at liftoff, so that no excessive noise reaches the upper section of the rocket. So it's acoustically insulated.
5, 4, 3, 2, 1.
The sound pressure at liftoff would destroy the satellite technology in the upper stage of the Ariane 5. It's a pressure so high that it can kill a person standing 1 kilometer away. The huge jet of water has to start cooling the launch table immediately after liftoff, but it must never hit the rocket. Factually, at the very moment of liftoff, the entire launch table lies under a blanket of water. The highest structures in the Kourou launch site are the ELA-3 lightning conductors. Over 100 meters high, they protect the Ariane 5 from dangerous lightning strikes that could cause fires or damage the electronic equipment. The Ariane launch site is 15 square kilometers and lies only 2 kilometers from the Atlantic Ocean. From here, the launchers can head for polar as well as equatorial orbits.
The launch angle is decisive here. Rockets can be dangerous. Kourou is such an ideal location because without any restrictions, we can fly over the sea right away. And that means there's no danger to the local population.
In technical terms, Ariane 5 is the safest launcher in the world, a fact that is due to the bundling of Europe's aerospace expertise.
If you work on Ariane projects, there is this extremely positive motivation to work together internationally with all the ESA member states. Each of these countries contributes some element or other to Ariane being assembled and launched.
This mission now sees a very special Ariane 5 standing on its launch pad. For the first time, 4 European navigation satellites are being transported into space simultaneously. 6 kilometers from the launch pad, final preparations for the launch are underway in the Jupiter Control Center. In a few hours, every seat here will be occupied, and the giant control room will become the mission's nerve center. The control center has a large spectator gallery and an internal secure area for flight control. Before the doors are opened, staff make the final adjustments to the settings on the communications equipment.
The control center is divided into 2 sections. The first 2 rows you see here are taken up by those responsible for running the operation.
These are the people who monitor the condition of the rocket stages they are responsible for throughout the entire mission. Tensions are high among all those involved. Despite quality management and inspections of even the tiniest of Ariane 5's components, errors can still occur.
There are always risks in any launch preparation, but we have to overcome them and provide the client with the required resources to meet the launch deadline.
All data from the entire mission, from Ariane 5 and its payload, come together here at the Jupiter Mission Control Center. Only 2 kilometers away from the launch pad, right in the middle of the spaceport, is the Launcher Control Center. Here, experts monitor all the data from the engines, the tanks, and the launcher's power supply on the launch table. On the building's bunker-like basement floor, launch preparations, according to a detailed checklist, have been going on for days, before the computers take over control later.
There's no start button in that sense. The launch itself is fully automatic. That means there are various people responsible for initiating the final sequences manually 7 minutes before the launch. And after that, it all runs automatically.
Processing the sheer flood of data arriving in the final minutes before liftoff is not humanly possible. It's now all down to the software and the hardware components of the Ariane 5. 6.8 seconds before the launch comes the final check to make sure everything has so far run simultaneously and in the correct sequence. If all parameters are correct at this point, there's no turning back.
Attention pour la séquence finale lanceur. 9, 8, 7, 6, 5, 4, 3, 2, 1. Allumage Vulcain.
The engine ignites. 7 seconds later, the computers give the go-ahead for the boosters, and 45 million horsepower of thrust propels the Ariane 5 into the blue skies over Kourou. The launcher is now on its way into space. This flight for the European navigation system once again confirms the great achievements accomplished by scientists and technicians from 22 nations. Every Ariane launch since 1979 is a testament to successful collaboration between very different people for a common goal in space travel. And it will continue. The Ariane 6 will supersede Ariane 5, and it will open Europe's gateway into space even further.